Hey everyone, we're going to start chapter 2 and we're going to pick up talking about what is a function. What's a function? What does it do? A function is simply a relationship. So a function is a relation. And what that means is it takes inputs and gives outputs. All the possible inputs get called the domain, and all the possible outputs get called the range. So, if I've got two values right here, I've got my domain. I take a point from my domain. Right here, my function comes along, takes that point, and assigns it to another point in my range. So that's my function f, mapping some x to another point f of x. Now what makes it a function is one specific input gives one specific output. Corresponds to only one output. So f of 2 is equal to 3. I don't know anything about all the other numbers, but definitively f of 2 is equal to 3. 2 goes with 3. 2 doesn't sometimes go with 3, or maybe sometimes 2 can go with 4. That's not a function. The input corresponds to one output. So, is this a function? 2, 3, 3, 4, 4, 5. This list of inputs, yes, that's a function because each input, 2, only appears once. 3 only appears once. 4 only appears once. What about this set of points? Is this describing a function? 2, 3, 3, 3, 4, 3. Yes, once again, that's a function because 2 appears once, 3 appears once, 4 appears once. Each input gets paired with a specific output. So what about this last one? 2, 3, 2, 4, 3, 5. Right here. See, look. 2 is sometimes 3, sometimes 4. That doesn't work. That's not a function. So, when it comes to do equations describe a function, we solve for y. And take a look at what results. Minus y is equal to negative x squared plus 37. Y is equal to x squared minus 37. Y is equal to x squared minus 37. Any value I put in here, I'm only going to get one y. And this was y to the first power, so yes, this is going to end up being a function. Whereas over here, if we go and we solve this, we're going to have negative y squared is equal to minus x plus 37. Y squared is equal to x minus 37. And then we take the square root, and we get that y is equal to plus or minus the square root of x minus 37. That's a problem. We can't have this plus or minus because if we do, then it's not just one specific output. There's a plus case or a minus case, and we just can't have that. That's not a function. You could maybe describe a relationship like that, but it wouldn't be a function. It's a mapping, not a function. I needed to abbreviate. So, what's function notation? For function notation, we have f of x is equal to x squared and so on. X squared minus 3x minus 4 is equal to whatever. But it's this right here is f of x. F is the name of my function. X is the input of the function. And what's f of x? That's the output. So f with input 1 would be equal to 1 squared minus 3 times 1 minus 4. 1 minus 3 minus 4, so that's negative 2 minus 4, negative 6. We would say that f of 1 is negative 6. I could also put a variable in there, so I could have f of y squared, and that would be equal to y squared minus 3 times y squared minus 4, y to the 4th minus 3y squared minus 4. Graphing, if I have something like f of x is equal to x squared, what I'm going to do is I'm just going to resort to making a chart, but not y. We're going to do f of x. So we might have negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and so on. Oops. Not sure what that was. And then I'd go and I'd take my axes and I'd draw, let's see here, so it goes through 0, 0, 1, 1, 2, 2, 3, 4, 3, 5, 6, 7, 8, 9, like that, a little bit better on that side, and I'd get my graph. Or I go ahead and I turn on my calculator here, and I'd go and I'd say, all right, calculator, I need you to graph x squared. And we'll go, not a second, we'll go to zoom, and I'm going to just zoom standard here. And there we go, x squared. Now, one of the main things about looking at the graph of a function is we can determine if something is a function using what's called the vertical line test. Simply put, I take a vertical line, and if it passes only once, then yes, it's a function. If it passes through the function only once, then yes, it's a function. And that's anywhere along the line. It has to be only once, then it's a function. Something like this over here, number 4, there's a spot where it passes only once, but for the majority of the spots, it passes 2 times. So it's not a function. Likewise with number 5 here, this passes through 2 times, so it's not a function. What about range and domain? I mentioned that the domain of a function is all the values that are that go into it. It's all our inputs. So if I had the set of values 1, 2, 2, 3, 7, 8, my domain would be 1, 2, 7. My range would be 2, 3, 8. All the points that come out of it, all the points that go into it. Domain versus range. So for number 1 right here, my domain starts over here at, call it -2, and then it's just going to keep going to positive infinity. And since this seems to be closed, this seems to be in it, I'd say my domain is -2, infinity. What about the range? Well, my range starts here at 0, and then it goes up to, I don't think this is supposed to be a horizontal asymptote. I think this is just going to keep increasing. So this is going to go up to, again, positive infinity. So this would be a range of 0 to infinity. What about number 2 here? For number 2, it looks like my domain on this kind of quadratic right, there's no real limit to where the range could be. Over here is fine, over here is fine, that's good, that's good. So I'd say that my domain would be -infinity to infinity, or it would be the set of all real numbers. What about the range? Well, it looks like the range caps out right here at, call it -2. And then it just keeps going down to -infinity. So the range of this would be -infinity all the way to -2. That would be the range. Number 3 here, this is a function. It doesn't pass to horizontal line test, but it does pass the vertical one. It doesn't need to pass horizontally, like this intercepting a few times is okay. Just like over here, this line intercepting a few times is okay. And this actually, there doesn't seem to be any hard stops like over here or over here for this. It looks like this domain is going to be all real numbers, -infinity to infinity, and the range is going to be the same thing, all real numbers, -infinity to infinity. Number 4, the domain, again, all real numbers are allowed. But for the range, this right here, and I might have to have a little bit of knowledge, but I can see just with how flat this gets, my range is never going to get below 0, and it's actually never going to get to 0. It doesn't actually end at 0. I don't see it going to 0. I can't make that assumption. So my range bottoms out at 0, and it's going to go on to infinity. The argument could be made for this problem right here, number 1, that this was supposed to be an asymptote 2, and maybe this should have come off a little sharper and not turned up so steep. But I think if I wanted to show that this was an asymptote, what I actually would draw is I would actually draw it coming off of here, turning sharply, and then I would extend this out and show, look, this gets really flat for a long time. I'd make sure that everyone can see that it's flat. Just like over here, this turns for a long time, and we can totally see that it's flat. Okay, now that's it for this video. I'll see you next time, and we'll go over some exercises. Thanks.